This is Algebra 2, Chapter 10, Section 4, in which we study infinite geometric series. Okay. What we're talking about with an infinite geometric series is it's geometric, so you're multiplying by something each time, but it goes on and on forever. Now, these things can either be convergent, which means you can get to an answer, or it can be divergent, which means you can't get to an answer. Okay. The question is, how do you tell whether you've got a convergent or divergent series? It all depends on your value of r. If r is between -1 to 1, then the series is convergent. If r is outside the zone, between -1 to 1, if it's anywhere outside of that, then the series is divergent. Notice it's not or equal to, it's strictly less thans. So a value of 1 is outside the zone. A value of 0.99 is inside the zone. It has to be in the zone to be convergent. So our first job is to decide whether we're looking at convergent or divergent series. So we have some values here, 2, 3, 4.5, and going on forever. We need to figure out r. r is the second term divided by the first term. That's the easiest way to find r, is just to take number 2 divided by number 1. 3 divided by 2 is 1.5. So r is 1.5, that's out of the zone. So I'm going to report that it's divergent. Okay, remember our zone is between -1 to 1. Now let's consider this one, 100 minus 50 plus 25 minus and so forth. Okay. Notice this negative here. And before we had addition. Technically speaking, you're adding -50. We just get lazy and combine that down to a minus 50. Well, r is still second term, -50, divided by first term, 100, which is -1/2. That's in the zone, so we would report this series to be convergent. It will get to an answer. Now, if our series is convergent, then we can find the answer for it. And there's a really simple formula that goes very smooth. It's a lot easier than finding one for a finite series like we did last time. The sum of an infinite series is a1, the first term in the sequence, divided by 1 minus the r value. Okay. They like to be sneaky tricky here, guys. They're going to ask you to find the sum of the series if it exists. Now, to get there, you have to find your value for r anyway. Make sure it's in the zone if you're going to work with this. So we have some values. 4 minus 2 plus 1 minus 0.5 plus blah, blah, blah. Okay. First, we need r. Second term divided by first term. -2 divided by 4 is -1/2. That's in the zone, so we can do the sum formula. a1, the first term, is 4, divided by 1 minus the r that we just figured out. Well, 1 minus -1/2 is 1.5. 4 divided by 1.5 gives me an answer of 2 2/3. And we were only able to do this because r was in the zone. Okay. Let's consider this one. 16 plus 20 plus 25 plus and so forth. The second term divided by the first term, 20 over 16 is 1.25. It's out of the zone. It's divergent. Or you could say it does not exist, and the mathematical shorthand for that is DNE. If you write DNE, I'll understand you mean does not exist. If you want to say divergent, that's fine as well. Now, like we've talked about the last couple of videos, we like to use sigma notation in math because it compacts the thing down into a smaller package. With infinite series, this makes life so much easier. First off, you need to recognize the symbol for infinity. That's the tip-off that you've got an infinite series going from k equals 1 to infinity. Your formula then would be a1 times r to the k minus 1. A1, that tips me off to the first term. R tips me off right here where R is. So the first thing we have to do if we're going to find this sum, make sure R's in the zone. 3/4, that's between -1 and 1, that's good. Now we can plug into the S formula. 12 for A1 divided by 1 minus R. 1 minus 3/4 is 0.25. 12 divided by that gives me a sum of 48. Okay. Now, infinite geometric series, are really useful in turning repeating decimals over into fractions. I know some of your calculators have ways to do this. Don't ask me because it varies randomly and I just prefer to use the arithmetic way here anyway. So they're going to ask me to do 0.21 repeating as a fraction. Well, 0.21 repeating means 0.21, 21, 21, 21, 21, and so forth, which I can break down a little bit. That would be 0.21 plus 0.0021. Now I've got 4 digits, so I'll need 4 zeros on the next one. If I continued going, I would need 6 zeros, 21, then 8 zeros, 21. But I have enough here to find what I need. I know my A1, and I know how to get R as the second term divided by the first term. And my calculator gives me 0.01. That's in the zone, so we're good. S then is A1 divided by 1 minus R. 0.21 over 0.99. To simplify that, all I have to do is move the decimal over 2 places. Gives me 21/99, which then reduces to 7/33. Okay. Make sure you know how to do it this way because I believe on the test I'm going to ask you to show the work. It does no good for you to just punch that into a calculator and get an answer. I want to see how you do it. So make sure you understand the approach. We're going to do one more here, and this one is really tricky to a lot of people because they don't pay attention to the details. This number 0.31 repeating, the repeating is only applied to the 1. So we're talking about 0.311111111. Okay, not 313131. Well, this is 0.3 plus 0.01 plus 0.001 plus the next one will be 3 zeros and a 1 and so forth. Well, this doesn't look like a geometric sequence unless I cover up the 0.3. If I covered up the 0.3 here, these terms do look like a geometric sequence. So I'm going to find the value for those terms first. I know the A1 of that sequence. R is this second term divided by first term gives me a value of 0.1. Now I'm in business. 0.01 for A1 divided by 1 minus R. 0.01 over 0.9. I need to move the decimals 2 places. 1/90th. That's all of this part. Plus, we still have this other number. 0.3 is 3/10. And then when I add those together, I get 28/90ths because I had to get a common denominator. And then 28/90ths reduces to 14/45 because they're both divisible by 2. Okay. Again, make sure you understand the process here, because on the test I'm going to ask you for showing the work to get points. It's not just going to be punch it in a calculator and get an answer. You're going to have to actually do some mathematics here. If you had questions along the way, hopefully you wrote those down. Bring them in with you, and we will see you in class.